So, hello students, welcome you all on YourPedia. So, my dear students, this video is specifically for the mechanical students for HPCL. And you know that in HPCL, one subject is COA, that is Computer Organization and Architecture, which mainly consists the four important subject of computer science, that is COA, Computer Organization and Architecture. One is operating system, one is database management system, and one is programming language, including the concept of OOPS. So my dear students, this subject, I think you just consider at least 5 questions or 5 marks problem from in the subject COA in your exam. So this is very important subject, important paper, and keep in mind, my dear students, if you are preparing for HPCL and specifically for the mechanical students, so I just gone through the previous papers, and the questions, the level of question is very easy. So you can't try to skip all those concepts because that is belongs to the mainly the computer science streams. Don't think like that. You need to cover all the stuffs, and we, the YourPedia team, are trying to provide you the complete detailed syllabus of that subject, that is computer organization and architecture. So this video is basically for the mechanical students, and I just pick up one subject that is called the operating system, and in this video I am trying to cover some part of the operating system, and in the next video also I'll try to cover the operating system, the remaining part. Fine. And in this video you are going to see some MCQ type question which you may face in your exam. So let's start with the problem. So first of all, in operating system we need to know what a operating system is. See, my dear students, operating system is a software. First of all, keep in mind, it is not a hardware, it is a software. And what the responsibilities of this software? And software means it is a set of instructions they are going to execute and perform some task. So what is operating system? It is an interface, it is an intermediator or the interface between user and the hardware. I, as a personally user, when I am trying to use the computing machine and try to run some applications, and I just need some hardware. Hardware maybe we have many hardware, IO input devices hardware, keyboard, and then the speakers and all this stuff. So it is an interface between hardware and a user. So you can see here what a operating system is. An operating system is a fundamental software that manages the hardware and software resources of a computer. So that is the responsibility of operating system, and the main point is it provide a user interface and coordinate the execution of the program. So what is operating system? It is an interface between user and hardware. Keep in mind. So you may face one problem, what operating system is, and they will just give you 4 options. You need to try or mark that option which contains the word interface. Now moving ahead, what the operating system is and what are the responsibility of operating system. Operating system का responsibility क्या है? अगर आपने देखा होगा, if you have the laptop and in your laptop one operating system that is called window. Fine. Window is an operating system who is going to execute who is going to manage many of the stuff. Fine, my dear students. So what is the responsibility of that window operating system or any operating system? So keep in mind, my dear students, operating system, the main responsibility is process management. It is trying to manage all the process. Now what do you mean by a process? Keep in mind, listen carefully, what is process? A program under execution is called a process. Whenever you are writing some program, you are downloading some applications, until unless you are not going to click that application will not be open automatically. You need to click that program. Fine. So until unless we are not clicking that thing, that is a program, means it is just a set of instructions. And when you just click on that part, it is going to, like if I just try to open a VLC player or any media player, I need to click on that part. Fine. Then it convert into a process. So what is process? A program under execution is called a process. So what is the first task of operating system? It is trying to manage the process. Fine. We are trying to open many of the process at the same time, but which process are going to execute, that is totally decided by operating system. Now the second need memory. We know that हमारे सिस्टम में, हमारी कंप्यूटिंग डिवाइस में we have the limited number of memory. So how efficiently we have to use that memory? That task is done by operating system. Fine. Next, in my computer we have many file or file systems. So how to manage the files, how to put the restrictions, how to fetch the file, all those stuff or the management of file is also done by operating system. So what are the main tasks? It manages the memory, it manages the process, it manages the file system. Next is it manages the devices. Devices means input and output devices like keyboard, like speaker, like CPU. Fine. Next, security. It provides the security, it provides the system performance. Why system performance? So it is trying to execute those process and it is trying to utilize the CPU as much as possible, and if we utilize the CPU in a proper manner, it means the performance of our system is increases. That's why system performance monitoring and the networking part. So talking about a conclusion, what is the main responsibility of an operating system? It manages the process, it manages the memory, it manages the file system, it manages the IO devices, it manages the security, it manages the networking, it manages the next security and the user interface and system performance. Now my dear students, you know that you are well aware with the main two operating system, that is iOS operating system and Windows operating system. So what type of characteristics these operating system has, that comes under the topic of what are the types of operating system. So mainly we have 5 main type of operating system, that is batch operating system. They are very old. So in batch operating system, actually what happens, whenever we are trying to execute any process, single process are not going to be executed. A bundle or a batch of process are first selected, then they are going to execute it one after another. Fine. That is called the batch operating system. A batch operating system is designed to handle and execute batch of job. This word is very important. They are going to execute batches of job without user interaction. Fine. Now user prepare the jobs. We are trying to prepare a bundle of jobs, and then OS gives the one job to the CPU, and they are now in the executing state and submit them to the system. The OS collect these jobs and execute them in batches. Fine. So we are going to select, suppose we are going to select 10 processes. After getting the 10 process, after getting a bundle of 10 processes or batch of 10 processes, then OS try to execute the one process one after the another. Fine. But suppose that only one process came to me and my batch size is 10. So I have to wait for the next 9 process to come and fulfill the complete batch. That is batch operating system. Now you can see the advantage: efficient for large job of similar types or similar needs. Fine. Also you can go with the disadvantage also. The second is multi-programming operating systems. Keep in mind, my dear students, these are the 3 different type of operating system. One is multi-programming, one is multitasking, and one is multi-processor operating system. So you need to find the difference between all these. One is multi-programming operating system. See, a multi-programming operating system allows multiple programs, as the word suggests, multiple program to reside in the memory, that is in the main memory, and be executed simultaneously. Fine. It increases the CPU if a number of processes are executing simultaneously. It means we are going to use or we are going to utilize the CPU as much as possible. That's why CPU utilization is going to be high, so that the CPU always have to execute one process. Fine. But the point is now, what is multitasking operating system? In multitasking, it is similar to multiple programming, but they are depend upon some time variant. It means the switching between the process is too high. one process executed suppose for 5 minutes and then the next process and then 5 minutes for the next process. It means they are switching one after another, and even the switching is done in such a fast way that we are not realizing that yes, the multitasking is happen or the switching is going to be happen. That is so fast. So here you can see what the multitasking operating system is. It allow multiple tasks to be executed simultaneously, but the point is rapidly switching between them. Each and every process are switching one after another. This gives the illusion that the tasks are running concurrently. हमें लगता है कि वो टास्क concurrently हो रहा है, but एक्चुअल में वो नहीं हो रहा है, उनमें स्विचिंग इतनी फास्ट होती है. फाइन, that's the multitasking. So what is the basic difference between multi-programming and multitasking? In multi-programming, again multiple programs are executed simultaneously, but in multitasking, multiple programs are switching in a fast way. We are assuming that one process is already completed. Fine. And the next is multiple processor. Normally in our system we have only one processor, and suppose we have multiple processors. So you know what is processor? It is the heart of the computing device or the computer. So if we have multiple processors, it means one processor is trying to execute something, another process is trying to execute something. That means multiple programs are executing some parallelly. Fine, that is multiprocessor. Multiprocessor operating system are designed for the system with multiple CPUs, central processing unit. Sorry, it coordinates and manages multiple processes to work together on a single task, on a different task concurrently. It means एट ए टाइम अगर हमारे पास अलग अलग CPUs होंगे तो वो अलग अलग टास्क या सेम टास्क के अलग अलग मॉड्यूल पे काम कर रहे होंगे, तो हमारी CPU यूटिलाइजेशन बढ़ेगा और हमारे टास्क जल्दी कंप्लीट होंगे. दैट इज द बिग एडवांटेज ऑफ मल्टी प्रोसेसर ऑपरेटिंग सिस्टम, because ultimately who are going to execute the process or the program? I can say that is only CPU, because CPU is the heart of the computing machine, that is central processing unit. And the next one is real time operating system. They are the operating system in which we are very strict towards the delay. We not required a single nanosecond time of delay. Fine. So a real-time operating system is designed to handle real-time applications like in ISRO, NASA or DRDO. We are required actually the real-time operating system that requires deterministic response time. Their response is very fast. A real-time operating system manages resource to ensure that the tasks are completed. That is a very important point. The tasks are completed within specified time constants. We don't require a single unit of delay. Fine, that is called real-time operating system. And my dear students, this part is very important. Keep in mind, you have to know what are the types of operating system, and you have to know what are the examples of each and every operating systems. So you can see here the batch operating system is IBM OS 360 old version. New version is multi-programming for multitasking, Microsoft Windows, Unix and Linux. For multiprocessor, Windows Server, Linux with SMP support, and IBM AIX real-time operating system is VxWorks, QNX and RTL Linux. So you have to remember all this stuff. That is very important. Now my dear students, actually what happens, CPU scheduling, it means which process is going to be executed. That is decided by the operating system and some other programs. So we have different type of CPU scheduling technique, and that totally depend upon the requirement. Fine, that is first come first serve. Suppose that many of the program came into the main memory, so then they are ready for the execution, and that's why we call them as a process. What is process? A program under execution. And when execution is possible, when that program reside in the main memory instead of the secondary memory. That's why when a secondary program from the secondary memory came into the main memory, we just call it as the process, because a process is a program under execution. Fine. Now we have different type of the scheduling technique, first come first serve. Suppose many of the process are reside in the main memory right now, so as which process came first, that is going to be executed first. That is called first come first serve. In the similar way, next job first, yes, shortest job next, round robin priority and multiple queue scheduling. Round robin is important. In round robin, we are trying to fix up a time. Means suppose that in the main memory 10 process are ready for their execution, but each requires some unit of time. So what happens, suppose that the first process which is trying to execute, he requires at least 1 day of 1 day for the CPU. Fine. It means the other process who require only 10 minutes for the CPU, they are having high waiting time. Fine, because if they are at the second place, they have to wait for the 1 day. That's why, my dear students, in round robin we are trying to fix up a time. It means a single process can execute at most in a single instance that much amount of time, so that the next process who is waiting like came in and then execute itself for that particular moment or that particular time quantum. Fine. So that's why in round robin we are trying to remove the problem of starvation. And what the starvation is, we are trying to learn now. Now we have two basic terminology, one is deadlock and one is starvation. So these two terminologies are very important. Keep in mind, you have to know the basic difference between the deadlock and starvation. See, my dear students, what a deadlock is. Suppose that we have two process. We have two process P1, process P2. Now process P1 require two resource may be the keyboard, resource may be the IO devices, any of the IO devices like the printer, like the CPU or any other, like the speaker or the monitor, anything. Fine. So process P1 require two resources. It already has one resources and it is requesting for the other resources. It is waiting for the another resources. Why waiting? Because that other resources is allocated to the second process. Fine. One process is already with the suppose I am trying to give you an example. See, my dear students, suppose that we have process P1 and we have process P2. They require we have resource R1 and resource R2. Now listen carefully, my dear students. Process P1 requested for resource R2. So process P1 require two resource. Fine. And process P2 also require two resource for their execution. हर एक को दो resources चाहिए, R1 and R2. And suppose करो, and let's suppose P1 is requesting for R2. It means R2 is not given to P1 right now, but R1 is given to or allocated to P1. Fine. Now R2, because R2 is requesting by P1, but R2 is already allocated to P2 and P2 requires or request for R1 because R1 is already allocated to P1. So the general scenario is R1 is allocated to P1, R2 resource is allocated to P2 process, P1 is demanding for R2, P2 is demanding for R1. And when a process can complete, when they have both the resources, it means each process has one resource and they are demanding for the other resource, and whatever they are demanding, that is allocated to the other process. Fine. It means they are waiting each other to release that resources, but they cannot wait because they have to complete their task, and for the completion of task they require both these resources. It means now no one is under the execution state. I am holding something, the other process is holding something, I require something, the other process also requires something, and whatever they require, we are holding the request of each and other resources. Fine, my dear students. So keep in mind, in this scenario, no process is executing. Keep in mind, in deadlock, all the system is in a block state, no process is in executing state. That's why this process or this scenario is called deadlock. Now we can move towards the definition part. What the deadlock is? Deadlock is a situation in multi-processing environment where a set of processes are blocked because a set of processes are blocked because each process is holding a resource and waiting for another resource. But what about the waiting resource? That is held by another process. That is the concept of deadlock. Keep in mind. Fine. Now next is what is starvation. See my dear students, what happened in the case of starvation? In deadlock, both the processes are waiting for each other. Fine, but in the case of starvation, suppose that process P1 requires CPU, but it cannot allocate the CPU because some other process P2 which is having high priority than P1, so CPU is given to P2. So P1 now waiting for the CPU to be free and then CPU is allocated to P1. But what happened? One process P3 whose priority is higher than P1 came, and after completion of the execution of P2, CPU is allocated to process P3. So still again P1 has to wait, and what happened again? Next P4 process whose priority is greater than P1, now CPU is allocated to P4 after completion of P3. In this way, P1 has to wait for indefinite period of time. That's why it is called starvation scenario. Keep in mind, my dear student, in deadlock, no process is executing, but in the case of starvation, one process has to wait for indefinite period of time, but other processes are in the waiting state or are in the running state because their priority are higher than this process. This is called the scenario of starvation. Fine. So dear students, you can see the definition of starvation because deadlock and starvation are these two most important points. So what the starvation is? It is known as indefinite blocking occurs when a process is perpetually denied the necessary resources. Why necessary resources? Because of the priority. Now what we happen? So what we have to do? We are using the concept of aging. What is the requirement of aging? Aging is the concept where we are trying to increase the low priority of a low priority process. We are increasing the priority of a low priority process. Fine, that's why now after some point of time, if we increase the priority of a low priority process, then he is in a situation to take the CPU and complete its task. That's why with the help of aging, we are trying to remove the scenario of starvation. That is the case of aging. So how to remove the starvation? With the help of aging. Aging is a concept. Now my dear students, two most important, again the terminologies are, one is internal fragmentation and one is external fragmentation. Listen carefully the basic difference. Sometimes students are confused in this terminology. So I am talking about internal fragmentation. What is internal fragmentation? Afterwards, we are trying to complete some MCQ type questions which you may face in your exam. See my dear student, this is my memory. And this is divided into some blocks. This is main memory. Fine. Suppose that the size of this block is 10 KB. Again 10 KB. Again 10 KB. And again 10 KB. Now we know that CPU only interact with the main memory. Fine. And we have some program which are in the secondary memory. Program P1, program P2, program P3, program P4, program P5. And when this program is came into the main memory for their execution, then this program is called as process. What is process? A program under execution. Fine. अब देखो, see, suppose the process P1 requires 8 KB space. The size of process P1 is 8 KB and this block size is 10 KB. So I am putting or keeping the process P1 in the first block. Now process P2 requires again 9 KB. So this space is enough. I just kept the process P2 here. Again process P3 8 KB. So I can put the process 8 KB in here in 10 KB, and one is process P4, that is 7 KB. So the point is, in first block out of 10 KB we are using 8 KB. It means this 2 KB is wasted. This 2 KB space is wasted. In the second block, out of 10 KB, we reside a process having size of 9 KB. So 1 KB space is wasted. 1 KB space is wasted. In process P3, 8 KB, process size P3 is 8 KB. So out of 10 KB, we are wasting 2 KB. And in the next case, 7 KB, it means we are wasting 3 KB. So the space which we wasted in a block is called internal fragmentations. Fine. So total internal fragmentation is 2 KB, 1 KB, 2 KB, 3 KB. 3 plus 2, 5 plus 1, 6 plus 2, 8 KB we are wasting the space. Fine. That is called internal fragmentation. But in the case of external fragmentation, see my dear students, listen carefully what the external fragmentation is. This is main memory. This is divided into blocks. Suppose again 10 KB, 10 KB. Suppose that 10 KB, this block size is also 10 KB. Process P1 having size of 8 KB. So we are residing process P1 here. Process P2 is 9 KB. Okay. Process P3 is again 8 KB and process P4 is again 7 KB. Now what happened? Process P2 complete its task. It means it is going to free this block. And next P4 is going to free the block. Now I have a space of 10 KB because process P2 complete its task, so it leaves the main memory, and in the same way process P2 complete its task, so it leave this memory. So 10 KB memory. We have 10 KB plus 10 KB, 20 KB block, 2 block having the size of 10 KB and 10 KB each are right now in my hand. But suppose that one process P5 who require 15 KB space wants to enter into main memory. So I have the 20 KB space, but that is not in the consecutive memory. That is not in a single block of a cell. That's why this free space, and this free space is called external fragmentation. We have the space, but we cannot keep any process because that space is not be in a single block or not in a consecutive manner. So what we are trying to do? We are trying to shifting the P1 and then P3 and P2 and P4 are now merging. This concept is called compaction. So why compaction is used? Shifting all the memory which are like used in the one side, all the free memory on the other side. That concept is called compaction. So external fragmentation is removed by the concept of compaction technique. So now we can go through the reading of internal and external fragmentation. You can see internal fragmentation occur when allocated memory may have some unused portion within it. That is called internal fragmentation. But in the case of external fragmentation occur when the free memory, we have the free memory, is split into small but the non-continuous block, and if a process want to enter into that block, that cannot be possible because they are not in the consecutive manner. That is external fragmentation. Now, my dear students, we are moving towards some of the important questions. So, what is operating system? A hardware component? No. System software? Maybe application software or network protocol. So, it is a system software or interface. Which of the following is an example of batch operating system? We know that IBM OS 360 is the batch operating system, and then multi-programming is IBM OS 360 new version. Fine. Now, in which type of operating system can multiple program reside in the memory at the same time? That is multi-programming, because that is called the multi-program reside in the main memory. Next, which scheduling algorithm assign a fixed time slice round robin? Because fixed time slice means a particular process can use the CPU for that fixed amount of time only. So, round robin. What is deadlock? A situation where a process are executed without waiting? No, there is no execution in the case of deadlock. A situation where a process are blocked due to lack of memory? No, due to lack of resources. A situation where a set of processes are blocked, okay, because each process is holding resources and waiting for the another resource held by, yes, that is the deadlock part. You can see here. Next, what is the starvation? Indefinite waiting. A situation where a process executed without delay. No, a process which has to wait for indefinite period of time, that process is in the scenario of starvation. So, a situation where a process is perpetually denied necessary resource. Yes, a situation where all resources are get equal. No, a situation where memory is fully utilized. No, so B is the right answer. Now, which technique is used to prevent starvation? Aging. We are trying to improve the priority. We are trying to increase the priority. That concept is called aging. What is internal fragmentation? Wasting space within allocated memory. Yes. Between? No. So, within. In a block, if we have some space which are free, that is called internal fragmentation. What is external fragmentation? Wasted space within allocated memory. No, wasted space between allocated memory. Yes. Which of the following is a solution of external fragmentation? Compaction. Memory compaction is the concept of external fragmentation, to remove the concept of external fragmentation. So, my dear students, these are the first part of operating system from the subject of COA, computer organization and architecture. And these are some of the important terminology and important concept which you directly face in your exam. So, my dear students, if you want to learn or want to join our dedicated module of HPCL, you can contact to YourPedia executive, or you can visit the URL of YourPedia educations. And if you have any query, please write on the query in either in the comment section box, in the comment of the video, or you can contact to me directly if you have any query related to the subject of COA, because COA subject consist with the four main subject of computer science, that is COA, that is database management system, that is operating system, and that is systems programming. So, that is very important part, and even though each and every subject has a huge durations of they are they are individually a particular subject in the CSC streams, but you have to be read the content precise in nature. No need to go in detail, and because this you are going to face only simple basic terminology. So, try to learn the basic terminology of all these four subjects. Fine. So, hopefully you like this video, you like this content, and if you have any query, please write it down in the comment section box. And if you want to join our module, you can join YourPedia Education dedicated HPCL module, mainly for the mechanical students. This video is for the mechanical students. Thank you.